Dear colleagues, today we were talking about radiofrequency safety assessment of volumetric virus coil for MRI of wrist joint at 3 Tesla. 1/4 of patients with disease of the musculoskeletal system suffer from osteoarthritis. It affects the joints, and MRI is the best way to diagnose and to visualize this disease. Then performing imaging of large joints, such as in the knee. Everything is okay, but correct visualization of small joints with thin and complex structure, like in wrist joint, it requires high resolution. That is why it is important to increase the quality of wrist MRI. We have 3 ways to improve image quality. The first is development of sensitive receive coils. Second is transition to high magnetic fields, and the last is development of more efficient pulse sequences. Everyone has downsides. It can be seen that increasing the static magnetic field and using effective pulse sequences are characterized by an increase of radio frequency power deposition. And we are facing a problem with RF safety restrictions. As a result, we can say that reducing the RF power deposition will be an indirect way to improve image quality. That is why decrease of RF power is interesting. But we need to talk about what is RF safety. I think everyone knows that heating in MRI is caused by an induced electric field. SAR, specific absorption rate, is used to assessment this process. Its rate of RF energy absorption in watts per kilogram. Using SAR, we can calculate the RF safety performance called SAR efficiency. Formulas for local and whole body SAR efficiency are presented on the slide. And how we will improve the image quality. Recently, a new concept of a dedicated metamaterial-inspired virus coil has been proposed for 1.5 Tesla wrist MRI. This coil not virus at all. It has virus connection only. Virus coil has virus in the structure. Coil based on an array of coupled split loop resonators that focuses transmit and receive capabilities of full body coil within the region of interest. This coil concept provided a dramatic decrease in maximum local SAR of birdcage coil. That means an excellent RF safety. You can see that local RF safety was increased to 4.3-fold and full body for 7.2-fold. Since SAR becomes a more important issue at 3 Tesla than 1.5 Tesla, it is interesting to transfer the proposed concept to 3 Tesla MRI. And the purpose of this work is to study the RF safety of the virus coil concept in 3 Tesla MRI. All calculations of electromagnetic simulations were carried out using CST Studio 2020. On the left, you can see the general model, which consists of a birdcage coil with shield and a virus coil in the center of system. They are tuned to the same frequency. And also we used a voxel model of human body in the Superman position. As a result of simulation, we obtain maps of the Earth magnetic field B1 plus and SAR maps for two setups, for body coil only and body coil with virus coil. As a consequence of using a virus coil, the transmission efficiency increased. The B1 plus field was 8.9 fold increase. And we can say that it's 8.9 square fold reduction of RF power needed to create the same B1 plus. We will check this value in the experiment with prototype on the next slide. But if we are talking about SAR efficiency, then we are using a virus coil. It was also increased for local and whole body SAR efficiency too. Let's go to the next slide. B1 plus mapping experiments. On the left, you can see the picture of virus coil in a protective plastic case, how it looks like. The experiment compared a standard 4-channel receiving coil with our virus coil prototype. Field maps we obtained using the double angle method. We are using salt and water phantom and also in vivo imaging with a healthy volunteer. As you can see, the virus coil has good homogeneity of B1 plus field in the center, where the region of interest is located, but B1 plus decreases towards the edges. Also in the experiment, we recorded how the reference voltage changes for two cases that you can see in the table. We see that we have 7.9 square fold reduction of RF power, and this value was in agreement with our simulation. And go next to the RF safety robustness study. This is the first case. We checked what happens to the RF safety if the coil is not positioned accurately. We rotate the coil by 5 degrees in ZX plane. And as a result, functionality of virus coil was decreased. That is why whole body SAR efficiency was decreased, and opposite local SAR efficiency was increased. And the last RF safety case, it's breaking one of the virus. On the left, you can see the number of virus of coil that were disconnected one by one, simulating a breakdown case. On the right, on graph, the reference dashed light means the reference model values of safety efficiency, not affected by breakdowns. And as a result, it turns out that the breakage of the center wires leads to a decrease in whole body RF safety, while local RF safety is increased. The breakage of the side wires leads to an opposite situation. And let's summarize this work. The experiment showed good agreement with computer simulations. Coil characteristics are robust for the minor imperfections. And due to the increased safety of the 3 Tesla MRI with our coil, Its use may be helpful in scanning patients with implants where safety is an issue. That's all. Thank you for your attention.
Okay.
I'm ready for your questions.
Okay, thank you very much for your talking. Do you have anybody the question? Okay, okay. Sergey Vasilyev, welcome.
May I ask, what are the situations when your coil can be damaged, and what could happen with it? Why do you simulate the break of the coil?
Okay, Sergey, construction of the core is very simple, but we need to have some cases of breakage of this coil. This is the most, how to say, this is the very good variant for breakage for coil, soldering one of the wires, because we have no any abilities to break this coil for another cases.
Thank you.
Okay, okay, thank you.